Okay, welcome students. So today we'll talk about mass and the difference between mass and weight, which we have done already, but again, and thrust and pressure. So this is the topic under the chapter gravitation. Okay, let's quickly start. So what exactly mass is? I have told you already. So just a little bit more we'll get to know about mass. So mass is the amount of matter contained in a body. So how much amount any body is containing? Everything of everything. Like for my system, there are lungs, there is heart and everything else. So I as a system, how much amount do my body contains? So that is mass. Okay. Its fundamental property is that it remains constant regardless of the location. Here in America or in Japan or maybe on a different planet, my mass will remain same. Okay, so scalar quantity, it is a scalar quantity. That means mass doesn't have direction. For example, we talked about velocity earlier, right? Velocity is speed with direction. That means you are going with a certain speed, 10 meter per second square, per second, but also you have a certain direction towards east or maybe towards north you are moving. So you have a direction. Here, mass doesn't have a direction, right? It just tells you the amount of content you have in your body, right? So it is a scalar quantity. Its SI unit is kg, okay, kilograms. So it is measured in kilogram and universally it is constant. So a brick has exactly the same mass on Earth, Moon, or even in deep space. Okay, so mass remains same, but weight can change. So what is weight? How weight is related to mass? Again, we have taken this concept already. So I'll quickly go through this. So weight is the gravitational force with which a celestial body attracts an object. So weight is nothing but mass into gravity or gravitational acceleration, you can say. Okay, so you know that if Earth has 9.8 meter per second square gravitational acceleration, it can be different for Moon or it can be different for Jupiter. So once this changes, weight changes, but mass remains constant everywhere. So this is what you have to keep in mind. And weight has a direction based on its location. So on Earth is pulling you downwards, right? Like this. So it has a direction. It's moving you towards a certain direction, not left, not right, not upward, but downward. So weight is a vector quantity. Okay, now these are the difference which you can see. So I don't have to go over this again and again. Okay, you know this already. Okay, right. So a 5 kg bowling ball has the same mass everywhere in the universe, but its weight can be different. It would be different on Earth, that is 49 Newton, and on Moon it would be 8.2 Newton. Okay, so this is the and also it will be in deep space, it will be 0 Newton. So this is how it is different. Okay. Now, coming to thrust. Thrust is force in action. What do we mean by that? Thrust is the force applied perpendicular to the surface of an object. Okay. So let's say this is your, object. Okay. Not object, this is like surface, let's say. So thrust is the force applied perpendicular to the surface of the object. So if object is moving like this, thrust is like this, perpendicular to it. Okay, if your object is moving in this direction, okay, so thrust is perpendicular, that is 90 degrees to it. Okay, its SI unit is, because it is force, nothing but force, but in action, like something is happening, and in that motion period, the force which is applied is thrust, right? So it is its SI unit is Newton. Now thrust is the total force acting on a surface regardless of area. It doesn't matter how much area is there, the total force which is acting on that surface would be counted as thrust. Okay, so how or why is it useful? A rocket launching upwards creates thrust by expelling gases downwards. So when a rocket is being launched, you can see it's expelling gases downwards, okay, and it is getting a thrust to rise, okay, above or everything else. Okay, a swimmer pushes water backward to move forward, so that is also thrust. And a book exerts a thrust on a table due to its weight. Okay, so it always acts for if this is book, okay, if it is lying like this, so it always acts like this. Okay, thrust. Okay, so a book exerts thrust on the table in this direction due to its weight. So this is a book. Sorry, not a good image of it, but yeah. Now, what is pressure? Pressure is force per unit area. That means, for example, okay, this I have to explain in a very, better way, because a lot of questions asked from pressure and students get confused. So let's see that pressure is equal to force upon area. So if more force is applied, the pressure will be more. If I'm applying more, force on my hand, the pressure will be more on this, right? And it's falling, like it's going down like this because of the force applied. But if the area is more, the pressure will be less. Now let me give you a good example of this. So for example, if you have taken a nail, okay, and you're putting in the wall, so you have taken it upside down like this, and then here you have taken it just the way you usually do, or others do. You're putting hammer here, okay? And you are putting hammer here as well. Okay. Now what happens, since here the area of the nail is more, right? Which is supposed to go to the wall. The area is more, the pressure applied is less. Even though if you are hitting it with the same power, okay, or same strength, you can say, yet it is not going in easily because the pressure has become less here in this case. And since the pressure has become less, it is not going inside the wall. But now once you have turned it the way it is supposed to be, so here the area is very, very less, okay, very small, and hence the pressure increases. Now once the pressure increases, after two hammers, okay, after two shots to it, we'll be able to put this nail inside the wall. Okay, so this could be one example of pressure, and how pressure is nothing but force acting per unit area. The more the area, the less the pressure. The less the pressure, the more the area. Okay, I said the same thing. Okay, so the less area, more pressure, and more area, less pressure. That is what I meant. Okay, now the SI unit is Pascal here. That is 1 Newton per square meter. Okay, so you can either write Pascal or write Newton meter square, because the unit of force is Newton, right? And if you ever get confused at how this came from, so you can just go ahead and check the SI unit for force is Newton, right? And for area is meter square. So upon. So this is the SI unit, but we usually use Pascal here. Okay, so now the relationship between the thrust and the pressure is nothing but thrust upon area, because thrust is nothing but a kind of force only. Okay, so don't get confused. This means the same thrust applied over a small area creates higher pressure. Okay. Now, okay, so how or where do we use? So for high heels versus flat heels. So when flat heels, you will, or flat shoes, sorry, not heels. How, heels could be flat. It has to have a little bit of, height. Okay, so the flat shoes actually have more area to it, right? More area to it. And the heels, if you can, imagine, would have less area. Okay, less area to it. Okay, let me just, okay, this is not a good representation of heels. You can just imagine something like this. Maybe, yeah, some pattern design, okay, right? Okay, so this has less area, right? So a woman, a 120-pound woman wearing high heels with, heel tips of around, you say 0.5 meter centimeter square, exerts pressure about 150 psi, enough to damage the wooden floor. Okay, so now you get it. The same woman, if she is wearing 50 centimeter square, shoes, flat shoes, will exert only 1.5, pressure, Pascal pressure. Okay, so you can see the difference. It creates a huge difference. Okay, now animal adaptation. So you have seen the camel have wide toe. Okay, wide padded feet to distribute the weight over the large surface area, reducing the pressure on the soft sand, so that their legs won't, dug deeper into the sand and will go inside. Okay, so that's why the weight is distributed, or you can say the mass is distributed because of the feet structure. Okay, because of more area. So the physics is being applied in biology and every different other place where you can imagine. So you have to know this. Similarly, elephants have broad feet to support their massive weight, because the weight is so much that if feet are very, very small, it would sink on the soft ground, and it will not be easy to come out of that with such a weight, right? Hydraulic system. So car brakes use Pascal's principle. How does it do that? Pressure applied at one point is transmitted equally to all parts of an enclosed fluid. Okay, now this allows small force on the brake and pedal to create a much larger force on the brake pads. And that's how this hydraulic system works. This I will talk later in our classes as well, because this is something important and we need to know. Okay, and it will take a lot of time as well. Okay, now straw physics. When drinking through a straw, you reduce pressure inside the straw by sucking it. Okay, so the greater atmosphere pressure outside pushes the liquid upwards, okay, into the lower pressure area. So the pressure you are creating the difference in the pressure. Okay, so once you are sucking, there is low pressure here, so from higher pressure to the lower pressure, this will move. Okay, and then you will be able to have your whatever juices you were having. Okay, so question again, I have answered this for you. Try answering this by your own first, or like try that. If you are not answering by yourself, just try why and how. I have answered this. Just give how, reasoning to yourself. Okay, this is how it works, right? So question one is, what is the formula to calculate weight? So W is, it is calculated with the help of mass and gravity, that is mg. Okay. Then second question is, if a person has a mass around, 60 kg, find their weight on the moon. And for moon, it is given the girth. Okay. The girth of the moon is given to you, g. So that is how you can calculate. Then coming to the third question, which exerts more pressure, a needle or a hammer of the same weight? Why? So this you can easily tell by telling the difference in the surface area. Okay. Now, one question more is there. Why do skis help you move across snow without, sinking? Okay. And that you have to tell. You have to think about it. Okay, so you have learned about mass and weight again. Okay, you learned about thrust and pressure, all these concepts. So thank you so much for, okay, these homeworks, just let me tell you. When we will discuss in class, we'll talk about, homework and all. For now, you have to avoid, just try using the, doing the quiz first, right? And this we have already done, so just ignore this. And you can try this one at home and let me know if you have any ideas related to that, and we can enhance over that. Okay, so homework is for if we'll be doing regular classes, then I'll tell you how to do it. Okay, then okay, thank you so much for joining the session. We are done with this chapter. Hope to see you soon in the other chapters as well. Okay, and if you have any queries, doubts, you can ask me. Take care. Bye bye.